Okay, in this problem, we're told that there's a kid, and I drew a picture of this. Great strategy. A kid standing underneath a street light. We're told the kid is 4 feet tall, that the shadow is 6 feet long, and that the kid is standing 18 feet from the street light. We're asked, how tall is the street light? And again, I mean, there's lots of different ways to do this, but I'm going to put this in a coordinate grid, and we're going to write an equation for a line in order to solve it. So, to write the equation of this line that passes through the kid and the street light, first we need to know the slope of the line. So, traveling from, A to B, and A is just 0, 0, and B is, let's see, 3, 2. Our change in X is 3 minus 0, and our change in Y is 2 minus 0. So 2 and 3. So our slope, which is change in Y over change in X, is 2 over 3. And these are things, by the way, that when you draw the picture here, you could just see. I can look going from here to here. I can see we're traveling up 2 spaces and over 3. But I want to do the calculation because you may not always be able to draw a picture that's as simple and whole number-ish as this one. So anyways, alright, so next we want to write the equation. So this is find slope. Next is write equation, and because I know the y-intercept, I'm just going to use slope-intercept form, and that is y equals mx plus b. So y equals, our slope was 2/3, and our b, our y-intercept, is just 0, so I'm just going to leave it off completely. So there's our equation. Okay, so we have our slope, we have our intercept, and we have our equation now. And now I'm just going to plug in the x-coordinate beneath the stoplight. So we've got 6 plus an additional 18, so this is the point 24, 0, and we're trying to find C. It's very similar to the box problem. So let's go up here, find C. So y equals 2/3. And we plugged in 24, it's the x-coordinate beneath C, and that's 48/3, which simplifies to 16, and we'll toss our units back in there because this is measured in feet. So the street light is 16 feet tall. Okay. There we go. Oh, let's just go over our process again. So our process again was we sketched a picture. We can tell that we're dealing with some collinear points. So I superimposed our problem onto a coordinate grid. And then I picked points A and B, and I wanted to write the equation of a line that passes through those so that I can use it to predict where C is. So to find the line that passes through A and B, I first had to find the slope from A to B. Remember, slope is end minus start equals change for both change in X and change in Y, and the slope ultimately is change in Y over change in X. Then we wrote, once we had our slope, we wrote our equation. Since I knew the intercept here, the y-intercept, I just used slope-intercept form. I got y equals 2/3 x. And then I take that equation and I plug in the x-coordinate for point C. And the x-coordinate for point C was 24. When I plug that in, it outputs a y-coordinate, 16. Outputs a y-coordinate, which is 16, which tells us that the street light is 16 feet tall.